without a calculator, we're going to find these values. So first it says find the slope of the graph y equals 3 cosine negative x. So whenever you see slope, the first thing you're going to think is you're going to think derivative, right? Because the derivative is the slope. That's the definition of slope. Okay, so we need to find the derivative of this function, and then we need to find the value of that derivative at each of these points, right? At x equals pi over 2 and x equals negative pi over 3. So let's find the derivative of this function first. So this function is y equals 3 cosine of negative x. And I wrote it in two different colors because I want you to recognize this is a chain rule thing, right? The outside function is 3 cosine and the inside function is negative x. So let's find the derivative. So y prime equals, what's the derivative of cosine? Well, it's negative sine. So we're going to write negative 3 sine. Now remember, we take the derivative of the outside function, so we took the derivative of cosine, and we leave the inside function still intact, and then we multiply it by the derivative of the inside function, which is negative 1. So what is this actually? Let's go ahead and write it over here. Y prime is actually negative 3 times negative 1, which is positive 3 sine of negative x. Okay, so now let's just evaluate this derivative at these 2 points. So first we're going to evaluate it at pi over 2. So we're going to think about our unit circle. And we're going to think, well, pi, let's see, let's plug this in. Y prime equals 3 sine of negative pi over 2 because it's negative x. Okay, so where is negative pi over 2? That's this angle right here. So it's negative 90 degrees if we can think about it that way. Okay, so what is the sine? Well, this point right here is 0, negative 1, and sine is our x coordinate. So the sine at negative pi over 2 is negative 1. So y prime of pi over 2 equals negative, or 3 times negative 1. So we have negative 3. Okay, what about at negative pi over 3? So let's do the same thing. 3 y prime equals 3 sine of negative pi over 3. So 3 sine of pi over 3, because, it becomes positive. And let's think about our unit circle. Pi over 3 is up here. And what are our coordinates at this point? That's 1/2. We're at 3 over 2. And our sine is the x coordinate. So we have 3 times the sine of that angle, which is root 3 over 2. So we could just leave it like that, or we could write it 3 root 3 over 2 like that if we wanted to. Either way is fine. All right, what is the limit as x approaches 1 of tangent of x minus 1 over ln of 1? And you're like, what? Limits? Yes. Limits, derivatives, and integrals are the main 3 parts of calculus. So we still have to remember limits, even though it's been a while since we did them. So what is the limit as x approaches 1? Well, let's go ahead and evaluate top limit separate from the bottom limit by direct substitution. So the limit as x approaches 1 of tangent of x minus 1 is 0 because, let's write this out. Tangent of 1 minus 1 is 0, and tangent of 0, that would be this one, which is 1, 0. And tangent is sine over cosine, so that's 0 divided by 1, which is 0. Okay, so tangent of 0 is 0. Okay, so the limit as x approaches 1 of that tangent is 0. And then we have the limit as x approaches 1 of ln of x. We're going to substitute in, well, that's ln of 1. And what's ln of 1? It's 0. Ln of log base anything of 1 is 0. So we have a L'Hopital's thing right here, which you probably guessed by the fact that I was evaluating them separately. So by L'Hopital's, we have the, we can take the derivative of top and bottom, and the limit is equal to the same thing. So this is equal to the limit as x approaches 1 of the derivative of the top, which would be secant squared of x minus 1. So we take the derivative of the outside with the inside still intact, then we take the derivative of the inside. Well, the derivative of the inside is 1. And what's the derivative of ln of x? It's 1 over x. Okay, so I end up with the limit as x approaches 1 of x secant squared of x minus 1. Okay, so now we're going to plug in 1 and we get the limit, or actually, you know what? The limit as x approaches 1, we're just going to say that's 1 times secant squared of 0. Okay, what's secant squared of 0? Again, we're going to go back to our unit circle and we're going to remember that 0 is right here and this has a point of 1, 0. And secant is the reciprocal of cosine. So the cosine of 0 is 1. Therefore, the secant of 0 is the reciprocal of that, which is also 1. So secant squared of 0 would be 1 squared. So we have 1 times 1 squared, which is just 1. So this whole mess, the limit as x approaches 1 of that whole mess is 1. All right, last one, we're going to find the x values of relative extrema. Now we look at relative extrema and we remember that what do? We take the derivative and then we set the derivative equal to 0 because we're looking for where the derivative, where the derivative is equal to 0. I was going to come up with like some fancy extra explanation for that, but that's really relative extrema happen where we have a derivative equal to 0 or undefined. So we got to find the derivative of this. Okay, so f prime of x is, what's the derivative of sine? Well, it's cosine. And what's the derivative of cosine? Well, it's negative sine. Okay, so we're subtracting that, so we get f prime of x equals cosine of x plus sine of x. Okay, and now we're looking for where is this equal to 0. Unfortunately, this one doesn't like factor or anything really pretty like that, so we can't just like factor it and set each factor equal to 0. But we can figure out where is the cosine equal to 0 on our unit circle. And you were like, man, I did not know we were going to use the unit circle this much. We are. So the unit circle tells us so much. All right, so let's think about all of our values. If we think about like the sixths and thirds, this is root 3 over 2 and 1/2, and this one's 1/2 and root 3 over 2. And do either one of those, if we add them together, even if one of them was negative, that wouldn't give us anything we need, right? That still wouldn't give us 0. Okay, so those ones are out. And then let's think about all of these ones here. These are like the zeros and the ones and the zeros and the negative ones. If I add those together, are they going to get 0? No, because like 1 plus 0 or 1 minus 0 or 0 minus 1, it doesn't matter. No matter how I put them, there's no way that those are going to equal 0. Okay, so as you can probably guess, I saved the best for last. Our fourths, okay? So our fourths here, this is root 2 over 2, and this is root 2 over 2. And let's see, the x's are negative here, so we have negative root 2 over 2 and root 2 over 2. And then this one, the x's and the y's are both negative, so we have negative root 2 over 2 and negative root 2 over 2. And then this one, just the y is negative, so we have root 2 over 2. Just doesn't want to write there. Let's see. There we go. And negative root 2 over 2. Okay, so we have all of these. Which ones of these, if I add them together, am I going to get 0? Well, not those and not those, because they're going to either be positive or negative. But these are opposites, right? So these are my two relative extrema. So what are these? What are these values? Okay, so we have 0 fourths, 1/4, 2/4, 3/4. So that's 3/4 of a pi, or 3 pi over 4. Then 1, 2, 3, 4, 5, 6, 7/4, so 7 pi over 4. Those are the two places that would make this equal to 0, which is my derivative. So these are my two relative extremas. So now we got to do an f prime number line. Okay, we got to do an f prime number line to see whether these are maxes or mins or maybe neither. Because anytime you find relative extrema, remember you have to check them to make sure, because sometimes you have one of those like loop loop and like, you know, it goes and it like tapers off and then it keeps going, and that's not an actual relative extrema. Okay, so just because we found a critical number doesn't mean it's a relative extrema. The other thing I want to tell you before we do our f prime number line is that, see, this gave us this interval 0 to 2 pi. That's super important because this is a periodic function. So a periodic function means that I could go like around and come back, and like I would get back to this one, right? So if I start here and I keep going and then I keep going around and I stop, that one is this, it would also have a derivative that's equal to 0. And you could keep going and going and going forever like that. You could keep just, like if you hit this one and then you hit this one and then you hit this one and then you hit this one, it's going to go on forever and ever and ever. So they gave us this interval, and you want to be really careful because sometimes the interval will say something from 2 pi to 4 pi. So instead of having 3 pi over 4, we would say, okay, we went around 2 pi and we came around, so we had 2 pi plus 3 pi over 4, and then 2 pi plus 7 pi over 4. So you would add those together and figure out what those are, because you want to make sure you're being true to the interval that was given. Okay, back to the f prime number line. Let's pick some values and see if this is what the derivative is equal to at each of these places. Okay. So let's just pick like less than 3 pi over 4. Let's pick 0. So at 0, we have this point that is 1, 0. And when we add those together, we get a positive number. Okay. In between 3 pi over 4 and 7 pi over 4, we could just pick pi. Let's pick pi. And that is negative 1, 0. And we add those together, we get negative, right? And then bigger than 7 pi over 4, we could get back to this point right here, right? Because bigger than 7 pi over 4 would be 2 pi, and that would be positive again. Okay, so our function goes like this: increasing max, decreasing min, increasing. So we have a max at 3 pi over 4. I should write this, a relative max at, and it asked for x values. So at x equals 3 pi over 4, and then a relative min at x equals 7 pi over 4. So remember, it's going to ask either x values, you're going to give the x that we just found. If it asks for coordinate points, you're going to give x and y, and oftentimes it's going to say, what is the max value at this point? That's going to be your y value. That's going to be your output.